Hello guys, welcome to my channel. Today's our Codechef problem is make Bob win, right? So what does the problem states? There are two like Alice and Bob are there, right? And they are playing a game. They have with them a binary string S. Alice and Bob alternate makes moves with Alice going first. On their turn, a player does the following, right? So what they can do is choose any substring of length S, right? And all those characters are, if the all those characters are same, deleted from the S and concatenate the remaining part, right? So uh, now Alice wins immediately when S does not contain any occurrence of 1, and Bob wins immediately after S does not contain any occurrence of 0, right? It is a binary string containing a 0 and 1, right? Note that the string initially does not contain any occurrence of 0, then Bob wins. See, Alice goes first, and as there is only ones and no zeros, then Bob wins automatically, right? Now, Bob wants to win the game, right? So there, for before starting the game, he can flip some characters of S, right? So basically, he can choose any index, any number of indexes from the string, and we can alter the one into zeros. Okay. So now we have to return the minimum number of flips Bob needs to ensure he can win. Okay. So for example, suppose there are three strings, right? First is of one length, that is zero only. So now, as you can see, Alice goes first, so Alice wins, right? Because there is no ones. But Bob can change some zeros to ones, like before as it starts, right? So there's only 1 0, so Bob will convert this one into zero into one. Okay, so by making one flip, Bob can win. Okay, so that's why the output is one. Here 1 1 1 is there, so Bob will not flip any one of these because see 1 1 1 is there as there are no zeros, so Bob wins automatically, right? Now this particular string 0 1 1 0 0 1. Okay, so one output is one. Why? See, Alice goes first. If he do not flips any, then he will remove one. Okay, then Bob will remove these zeros, right? Then Alice will remove this one, so zero will remain. So Bob loses. So what can Bob do is Bob can flip this particular zero to one. Okay. So now Alice can remove all these three ones first or the single one. After this, Bob will remove this and there will be no zeros. So Alice won, right? So basically altering this zero into one, Bob wins. Okay. So hope you have understood the problem. Now see, what's the logic of for solving this particular problem? See, as you can see, the third example is here, right? Now, as you can see, like Alice can choose one, right? Like contiguous ones and remove it, and Bob can choose contiguous zeros and remove it. So this string is equivalent to this. Okay. So I because Alice can remove this zero singly or this two at the same time because they are contiguous. So contiguous can be counted as one. Okay, so we can write this string as this. Similarly, if three ones are there, then three ones is equal to single one only. Okay, then also output will remain the same. Okay, now so basically, if we do this, then there are our many cases have reduced to few ones. That is, there are few conditions only. That is, for this particular string, the conditions could be if 1 1 is there at the end, right? In between, no matter what is there, it remains the same, right? And either 1 1 is at the both end or 1 and 0 are both ends and remaining in between is 10. Okay, or both at both the ends is 0 and in between is 10. Okay, now as you can see 1 1 can is contiguous, so we can write it as this, right? And here also 1 1 are contiguous, so we can write it as this. Okay, and here also this is contiguous, so we can write two zeros as zero, right? This could be a this could also be a possibility of this particular string, right? Now see, in the first case, how can Bob win? If Alice starts, he will remove this one, then Bob will remove this zero, then Alice will remove this one, then Bob will be containing zero, so Bob loses. So what he can do is he can alter this particular zero to one. Okay, that's the zeros index zero. Okay, then Bob can win. So he has to make one change. Okay, for this particular string. Okay, now for this particular string, if both the ends are having 1, then what we have to do? We have to do nothing because see, here if both the ends are 1, that means definitely the count of 1 is greater than 0, right? But similarly, if I write like this, then also one count will be greater than 0. So Alice will remove this one, then Bob will remove this 0, then Alice will remove this one, then Bob will remove this 0, then Alice will remove this one. Okay. So basically, Alice don't have to do anything. Okay. Hope you have understood, right? 101 was the string. Okay. Now, if like there is a 1 1 and at the end there is 0, then what we have to do is see, Alice move first, so Alice will remove this one, then Bob will lose because there is one 0. Okay, so basically we have to make one flip. That's why 1 1 would make look like this and Bob wins, right? Because there are no zeros. And if there are two zeros at both the ends, then what can Bob do? Bob loses because see, Alice will remove this one, so Bob loses, right? And if I remove this particular 1 0, then also Alice will remove this one, then 0 remains. So basically, Bob will lose. So basically, he has to make all these both the zeros to 1 to basically to flip them, right? So he can the number of flips would be 2, right? So the maximum number of flips that Bob need to win is 2 only. Okay, and the case would be if 0 0 comes at both ends. If 1 1 comes at both sides, then he has to do nothing. Okay, if 1 1 comes both ends, or and if 0 or 0 or 1 are at the both the ends of the string, then he has to flip only one time. Okay, so this is the only case. Okay, so here I have written this particular case. I have written the test cases. Now I have taken n, the size, and then the string. I have taken one count variable that is equivalent to 0. If the length is equal to 1, then what we can do is if s of 0 is 0, that is Bob have to flip this 0 to 1. That's why the count is 1. Otherwise, the count would be 0 because 0 is already there, right? Else, if the string length is greater than 1, then we have to check. What we have to check? The 0 and n minus 1 index. If the, see, if both were zeros, then we have to increase the count to 2. We have to flip both of them. If this particular is 1, then we have to do nothing, right? If this particular is only 0, then we will increase the count. If this is 1, then we would do nothing. So basically, if two zeros are there at the end, then count would be 2. If 1 is at the end and 0 is at the end, then count would be 1 only. And if both are ones, then we would do nothing, right? And now if I run it, oh, okay, yes, the output is 101 as expected. And if I submit it, yes, it is submitted, right? So thank you guys. Hope you have understood the problem. See you in the next video. Till then, goodbye.